Well, good morning, Core Math 2 students. This is your Week 3 Lesson 2, and today it's all about identifying trigonometric ratios. So the first thing you might be wondering about is, what is trigonometric? What does that mean? Well, the word trigonometry comes from the Greek, and it means a branch of math dealing with measures of triangles. And so the abbreviated form is to call it trig. So that's what we're going to be working on for a significant part of this semester, is right triangle trig, or trigonometry. So in trigonometry, there are three big ratios, and so they're listed right here. The words are sine, cosine, and tangent. Now, you're never going to find those three full-on words on your calculators, but you will find the abbreviations sin, which is still pronounced sine, cos, which is still pronounced cosine, and tan, which is still pronounced tangent. So we do not call these sin, cos, or tan. That never happens. They're always sine, cosine, and tangent. Okay, so these three ratios, what does this even mean? How can we write these out? Well, if we look down here at this right triangle, so that's key. It's only going to be true for right triangles. And we're looking at angle A. It's the only angle that's labeled with a letter. So what we're going to be writing is a sine ratio for angle A, a cosine ratio for angle A, and a tangent ratio for angle A. And just like in regular class time, we sometimes have distractions or things go sideways, like that kitty. Okay, so how does this work out? Well, the sine ratio of angle A always places the opposite side length from angle A over the hypotenuse side length. So it's going to be a ratio of two numbers, but we have to locate where the opposite side even is. So from the perspective of angle A, the opposite side is the side across the triangle from it. This is opposite because that segment, that length, doesn't touch angle A at all. Has nothing to do with it. The hypotenuse, well, the hypotenuse is always in the same place on any right triangle. The hypotenuse is always across from the right angle. It's always across from it. It's the longest leg in the triangle. So that's our hypotenuse, always. No matter what angle we're looking at, that's the hypotenuse. Meanwhile, cosine of angle A, this ratio is going to place the adjacent side to angle A over the hypotenuse length in the triangle. So we've already labeled the opposite side. We've already labeled the hypotenuse. The only other leg is the one down at the bottom. It won't always be at the bottom, but it happens to be here. And this side is adjacent to angle A. It's next to angle A. It's touching angle A on one end, and it's not the hypotenuse. That's what makes this side the adjacent side. And lastly, the tangent ratio for angle A puts the opposite side from angle A over the adjacent side to angle A. Opposite over adjacent, and those are already marked. So one way that students remember what is sine, which sides, what is cosine, which sides does it go with, is something called SOHCAHTOA. SOHCAHTOA. S for sine puts the opposite over the hypotenuse. Cosine puts the adjacent over the hypotenuse. And tangent puts the opposite over the adjacent. SOHCAHTOA helps us remember which side lengths belong in which ratio. So let's take a look at the type of example that you'll run into on Delta Math today. So here in example 1, it says in triangle LMN, the measure of angle N is 90 degrees. Okay, so we have no real clue what this triangle looks like, but we know that there's a right angle, and that one is angle N. Now we also have two other letters, L and M, and we don't necessarily know which side goes where, but they do tell us all three side lengths, and so we might look at them first before we put in any labels. So NM, one of the legs, is 5. ML is 13, and LN, the other leg, is 12. Okay, so the longest leg is the hypotenuse. So I'm going to mark that as 13 across from angle N. Now NM is the shorter of the two legs, so I'm going to go ahead and put that 5 here, and I'm going to put the longer leg 12 here, just so that my picture looks right. And then for labeling purposes, NM was the 5. So M must be the angle up there at the top of my 5, and angle L must be over here as part of that long leg. So getting the labels and kind of getting the picture to look right is kind of the first step. Then it asks us what ratio represents the cosine of angle L. Well, Delta Math will just ask you for one of the ratios, but it might be helpful if we write out all of them. Sine of angle L, cosine of angle L, and tangent of angle L. We're going to write all 3 ratios. And the ratios themselves are just one number over another number. So keeping in mind SOHCAHTOA, the sine ratio wants to put the opposite side over the hypotenuse. So we have to focus on angle L. That's what we're focusing on. And we might go through and label the sides based on their position to L. So for starters, the 13 is the hypotenuse. That's not going to go by any other name. It's the hypotenuse. Then from angle L's perspective, across from angle L, that's the opposite side. And then the third side we haven't labeled just yet must be adjacent. It's next to angle L, but it's not the hypotenuse. So once we have the labels in place, it becomes a lot easier to write out the ratios. So sine puts the opposite over the hypotenuse. So the opposite is 5, and the hypotenuse is 13. That's the sine ratio for angle L, 5/13. If it asks you to write it as a decimal, you could divide this out and round the decimal. Cosine of angle L, that's going to put the adjacent side over the hypotenuse. Well, the adjacent side is 12 over the hypotenuse, 13. That's the cosine ratio for angle L. And lastly, tangent of angle L. Tangent puts opposite over adjacent. So from angle L, opposite is 5, 12 is the adjacent. So 5/12 is the tangent ratio for angle L. So head on over to Delta Math and do some practice on these trig ratios.